All right, here we go. We have a lesson today on factoring because it's about the quadratic formula, or excuse me, about quadratics and how to do factored form. This is a little reminder that you were supposed to take a formative quiz yesterday at home, and I think some of you may have forgotten. You need to get it done in class today if you had not already done it, in addition to all the other stuff we're doing today. It is only 7 questions long, so there's 6, I think. So it's not going to be too terribly painful. All right, next. This is an example problem that's a little more complicated than yesterday, but it'll tell me whether or not you remember how to do the stuff I taught you yesterday. Vertex form, all you need is the vertex, and you can write vertex form. But I want to be fair to you and warn you with this little red writing here where it says, recognize the vertical stretch / shrink. This is not a normal parabola. It has been stretched, so factor that into your answers. I'm going to pause for just a second while you try to answer those 2 questions that are on the board. What's the vertex form of the equation, and what's the factored form? So here's what you should have said for vertex form. That's the vertex. The vertex is -1, -2, but vertex form is where you write it like this. And I could just see somebody giving this answer just perfectly, switching that to the opposite, and then saying -2 at the end, and then forgetting the stretch, and then forgetting something else. The squared, okay, and then what else? A 2, because this should normally go over 1, up 1, and instead it went up 2. Up twice as high. Put a 2 in front. Raise your hand if you had it perfect. Nice. The other one, factored form. That one you use these 2 numbers, here and here. And that's 0 and -2. So I go y equals parentheses for the -2. That's a little more logical. And you go +2. That way -2 will solve it. It'll make it equal 0. And then the other one is at 0. How do I do that? I could just say x plus 0. Just do it just like the other one. But x plus 0 is actually just x. And so it'd be better to just say x. And then the last thing is it's still got the stretch factor. Don't forget. Over 1, up 2. So 2 in front. Raise your hand if you had that one right. Okay, good. And if you didn't and you understand it now, you're good. And if you still don't understand it, ask me. Yes? X minus 0 and x plus 0 are identical, so I am okay with that, yes. All right, moving on. This is just tell me verbally, are these factored, general, or vertex? What's that first one? General. Second one? Vertex. Third one? General. Fourth one? Fifth one? Sixth one? Factored. Seventh one? Eighth one? Or is it vertex? No, it's factored. Number 9 is what? General. And the last one? That one is general. All right. Now it's also, number 10, this is kind of a weird one. Number 10 is actually also factored form. Because you can't factor it any further. And it's also vertex form. How could that be in vertex form? Because it's at 0, 0. So if you wrote it out, you'd probably say instead of 2x squared, you'd say 2x plus 0 squared plus 0. Do you see that it's in vertex form, actually? This and this are the same exact thing. So it's in vertex form, and it's in general form because it's multiplied all the way out. All right. And it's also in factored form because you couldn't factor it any further than it already is. The only thing you could say about factored form is you might make the argument that for factored form you really should have wrote it this way, x times x, and then a 2 in front. And then it's more like factored form. So anyway. All right, moving on. This is just foiling. I'm not going to waste your time foiling. We've practiced that a lot already on the top 20 sheets. And on this, we're factoring. All we're asking you to do to take something from general to a factored form is to factor it. That's all you have to do to get it to that form. Okay? So to factor something, we've already done enough of these that I don't think I need to talk about the easy ones. I want to jump to the difficult kind, which are right... Actually, since I'm recording the video for the whole class, not just for you guys who already know how to do this, there's 300 kids that watch these videos when they're sick. I will just show one here. If I was going to make this one be a factored form, I would go x, and then how do you make a 4 with multiplication that also makes a 3 with adding? A 4 and a 1. And then should it be a positive 4? Yeah. All right, I'll use positive 4 and negative 1. Now, if I had tried that and it didn't work, I would just switch the signs around. But I'm going to check it. Outside and inside makes a total of, let's see, 4x and minus x makes 3x, and that's what I wanted. It's all about the checking the outside and the inside and seeing if that makes the middle. Okay, now I know you've already done enough of those that you're probably pretty good at them. Here are the tougher kind. What do you do when a is not negative 1? Now, when I gave you guys the factoring quiz, your average score was a 6 out of 10 because there were 4 problems on there that you weren't sure about, mostly because they had GCFs in them. What goes into all of these? 3 does, so you'd have to factor it out. What goes into both of these? Be careful. 4 does, but there's more. 4x goes into both of them. All right, and the last one is this one, and it's really important that you take out the right thing. Yes, 2 goes into all of them, but do you get that you have to take out negative 2? If the lead coefficient is negative, you have to get that out of there. Even if the graph was as simple as this, and it was totally factorable, negative x squared plus 2x plus 2, that would normally be factorable, and I could just factor it without taking the negative out. You have to take the negative out. You have to have a negative 1 in front, and then factor that out and say x squared minus 2x, that's supposed to be an x, and then minus 2. You have to take this out because factored form requires that that lead coefficient be the one that's negative. You can't have it inside with some other number. Like some people would say, why can't I just go like this? Negative x and x, and that'll make a negative x squared. That's true. But then you won't have the equation in factored form. The lead number is what's supposed to be negative, not the thing on the inside. All right, so final thing point I'm trying to make to you guys is you need to have factor out a negative. Would you try number 3, please? Even if you don't have that slide in your notes, I think you do, but if you don't, still could do it. And then turn it my way, everybody, and keep it turned. You might want to set it down because it's going to be a while before everybody's done. Keep it turned my way. It'll be probably, I'm guessing, 30, 45 seconds. Is that the factored answer that you're trying to show me? Turn it around and show it to yourself. Is that what you want? Is that factored? All right, in case you're starting on the wrong foot, we were trying to factor out a negative 2. You can't factor out a 2. You have to factor out a negative 2. Okay, turn it my way. Let me see. Many of you are not done yet. I'll give you another 15, 20 seconds, but hurry, please. Good. Good. I don't think that you factored it right. Can't see all of it, Mr. P. You haven't actually got the 2 sets of parentheses yet. We need the parentheses. Good, good, good. Something's wrong on the inside. Good. Can you put the negative, bring the negative 2 down and you'll have it. The negative 2 doesn't just go away. It's in the answer. All right, so first you take the negative 2 out, and then you have x squared plus 5x, and then I got to be careful with this last one, minus 6. And all I do to check to see if I did that right is I go this times this, and see if it makes that. And this times this, and see if it makes that. And negative 2 times negative 6 makes positive 12. There, I did that part right. Can I stop there? No, because I can factor it further. This can be broken up into parts, x, and how do I make a negative 6 by multiplying and use those same 2 numbers and make a 5? It's probably a 6 and a 1. It actually could be a 2 and a 3, but it doesn't actually work. So I'm going to save the time trying that and having it fail. A 6 and a 1. And now of those 2, I got to just try it. I'm going to go plus and minus and see if I did it right. outside and the inside would make negative 6x, positive 1 makes negative 5x. That's exactly the opposite of what I wanted, so therefore I changed the signs to be the opposite of what they are. There we go. So it should be the x plus 6, the x minus 1, and the negative 2 out in front. Raise your hand if you had that one. Okay, good. That's the hardest kind that you'll have today. So your assignment, we may do this factor race game at some future date, but your assignment is right there, factoring worksheet A, and I'm going to allow you to skip some of the problems because I know you're already good at them, and I don't need you to do tons of practice on things you're already pretty good at. So I'll tell you which ones you can skip. In service class, you may skip the 17 and 18 are true review problems at the end. You may skip number 17. And then you can skip 5 through 10, problems 5 through 10, and 17. So skip 5 through 10, no, skipping 17, doing 18. Okay, and that's all I have for you for today.